Hello friends, myself is Dada Saib Arekar, Assistant Professor in Mathematics. Dear friends, today we will discuss one of the simplest concepts in mathematics, and that is the sequence. Now, we have seen several examples of sequence just like 1, 2, 3, 4 up to infinity, minus 1, minus 2, minus 3 up to infinity, and so on. Okay. Now we will go for actual definition for a sequence. Now for a sequence, it is a function, and for this function its domain is set of natural numbers. There are several kinds of sequence. It may be sequence of real numbers, it may be sequence of integers, natural numbers, or sequence of complex number. But here we will focus mainly on sequence of real numbers. So we will go for a definition of sequence of real number. Take any function x for which domain is set of natural number and whose range is subset of set of real numbers. Then for such kind of function we call as sequence. Okay. See here, any function x from set of natural number to R is called as sequence of real number. It is called as sequence of real number. Why? Because its range is subset of set of real numbers. Now if we replace set of real numbers by set of complex number, then we would have got the sequence of complex numbers. That is the definition of sequence of. Now the terms of the sequence are usually denoted by small x1, x2, x3 up to infinity. Okay. Sequences are generally denoted by capital alphabets. Here sequence is usually denoted by x is equal to in bracket x suffix n, or capital S is equal to S suffix n, and so on. Here I have given several examples of sequence. First is x is function from set of natural numbers to R, whose terms are given as x1 is equal to 2, x2 is equal to 3, x2 is equal to 5, x3 is equal to 8, and so on. It is a sequence of real number. Second, another example of sequence is given whose terms are x1 is equal to 2, x2 is equal to 4, x3 equal to 6, and so on. Now there is obvious concept of subsequence. Like in a group, when we study group, then we will think or we will go for its subset, and that is a subgroup. Likewise here is for sequence we will go for subsequence. Very easy. Again take any sequence x of real numbers. Now here take a function capital S from set of natural numbers to set of real numbers, such that S of 1 is equal to say n1, S of 2 is equal to say n is equal to n2, S of 3 is equal to n3, and so on. Now here condition on n1, n2, and n3 is that n1 is strictly less than n2, n2 is strictly less than n3, and so on. Now let us form a composite function x compose capital S. Now for this composite function x compose capital S, its domain is set of natural number obviously, and its range is subset of R. Now it is given as x compose capital S of 1 is equal to xn1, comma x compose S up to is equal to xn2, and so on. Now here the terms of the composite function x compose S are nothing but xn1, xn2, xn3 up to infinity. Now we will get again a new sequence xn1, xn2, xn3 up to so on. This new sequence is nothing but the subsequence of original sequence x. Now here examples are given. Here sequence xn is nothing but curly bracket -1 plus 1 -1 plus 1 up to so on. Then we have taken its one subsequence as x to n. I mean the subsequence containing only even numbered terms of the original sequence. This is the one sequence. Again for the next example, here sequence xn is nothing but the sequence of natural numbers. Here I have taken sequence x to n minus, here I have taken subsequence as x to n minus 1. It is nothing but this sequence containing the only odd position terms, which are nothing but 1 2 3 5 up to x to n minus 1 is the subsequence of the sequence whose terms are 1 3 5 7 and so on. Again I have taken another subsequence, that is x to n, which is nothing but the subsequence containing only even position number in the original sequence, and so on. Next we will go for types of sequences. There are mainly two types of sequences. First is convergent sequence and second is divergent sequence.